the cells in the liver and produces that disease. In addition, HIV, which again we're going to talk a little bit about more later, directly kills immune cells that it infects, and that's what causes the more severe symptoms and diseases that you see as a result of that virus. All right. So we did actually have some early treatments to these kinds of viruses. We don't have antibiotics. That's one of the things I want you to come away with. Antibiotics do not cure viral infections. Number one. All right. So early treatments. Most of the treatments, and this is still true today, you can only treat the symptom. We don't have a lot of drugs against all these different kinds of viruses for some very important reasons. So most of that is just kind of treating the symptoms. If you've got a cold, you're going to be out for a few days. You just try and clear your sinuses and make yourself try and feel better. But there's really nothing we can use against the virus itself. The best thing we have against viruses are vaccines. And the first vaccine was developed by a gentleman named Edward Jenner in 1796. Does anyone know what our first vaccine was? Smallpox, I think I heard some people say. Yes, it was actually smallpox. So this is an illustration of Dr. Jenner administering the very first vaccination against a somewhat unwilling recipient, James Phipps. So let's talk about this experiment. So Edward Jenner was a really smart guy. He knew a lot about anatomy. He knew a lot about nature. And what he saw is that smallpox, when it infects people, it kills about 1 out of every 5 to 3 people that it infects. That's a pretty high mortality rate. But he noticed that milkmaids didn't get smallpox. They might have gotten a few little pox here and there, but they didn't actually come down with the disease. What he then noticed is that cows actually have another disease called cowpox, which is remarkably similar to cowpox, or smallpox rather. So he had this hypothesis. He thought maybe by interacting with the cows, they're somehow getting a lesser severe form of the disease, and that protects them. So what he did is that he took a small segment of the pox of a cow, and he kind of scraped it along the skin of James Phipps. And in what would no longer be considered an ethical experiment today, 3 weeks later, he did what's called a challenge against Mr. Phipps. So he purposefully infected him with smallpox. Now, lo and behold, Mr. Phipps survived. He didn't come down with the disease. So this was really the first vaccine that we ever actually developed. And in fact, the word vaccine comes from the Latin vacca, which means cow. So that was named in honor of Dr. Edward Jenner. Let's talk about another disease where our first real vaccine was created. So polio has been a disease that's been with the human race for quite some time. In fact, we found illustrations in pyramids from like 10,000 years ago that actually show poliomyelitis, this decrepit forming of the limb that you get occasionally with polio. So the disease itself actually predates historical record. We've been with it for a long time. Most of the time, when you get polio, it's asymptomatic or you get mild gastrointestinal distress because that's where it replicates, is in the gut. However, in about 1% of the people who get polio, that virus actually then spreads to your central nervous system and actually starts infecting and killing those cells. And that becomes the symptom of poliomyelitis, or paralysis caused by polio. Now, of that 1%, about 3% of those will die with the disease. So when you saw people with iron lungs from those photos back in the 1940s, that was because they could no longer breathe. They've lost control of their motor neurons in their lungs. Now, polio obviously is no longer a real concern here in the United States, but there's some important reasons for that. So polio is what I'd like to call the first true vaccine. The first one was taking a different virus and then challenging us. It was similar enough to smallpox that we were able to recognize it and defend against it. However, Jonas Salk in 1955 took poliovirus and he infected monkey cells. So polio infects a lot of different mammals, and he was able to get it to infect these monkey cells in a plate. And he did that because that allowed him to get more of the virus. So instead of, let's say, infecting a person and then getting a lot of poliovirus back, he did it in what we call cell culture. So once he grew poliovirus in these cells, he then inactivated them with formaldehyde. So basically what that does is the virus is there, the structure is there, but it's kind of a dead virus. It can't replicate anymore. So then he inoculated or injected people with this inactivated virus as the first real vaccine. Now, that worked actually pretty well. But as it turns out, there's 2 different forms of vaccines that we have. So if you get kind of your seasonal influenza shot, that would be an inactivated vaccine. That's injected directly into you, and they take influenza, they kill it with some kind of agent, and they inject it into you, and you mount an immune response against it. But there's another kind. Who's gotten the flu mist vaccine? Has anyone ever received that one? Well, that one actually is an attenuated vaccine. So instead of killing the virus, what we do is we actually kind of make it into a wimpy virus, such that it'll replicate a little bit, but it's really easy for us to fight off. So the first attenuated vaccine actually came out about 5 years later, and that was called the Sabin vaccine, after Albert Sabin, who made it in 1961. So what he did is he took polio and he grew it in human cell culture that we had. But instead of just growing it, what he did is he grew those cells at a lower than body temperature. So he did this. He infected the cells. He let it grow at a low temperature. He took it out, and he did this over and over and over again. And what eventually happened is the virus mutated and adapted to that lower body temperature. So the advantage to that is that you could then inoculate a human, and when their body temperature is much higher than that, the virus is adapted to a low temperature. It can't replicate well in a high body temperature environment. So effectively, instead of being a dead virus, it's a much wimpier virus. And that was one of the main ways that we could effectively launch a better immune response to it, because it is actually replicating your system. But it's not going to cause disease. Now, there are